It's Hannah here from Chore with Me, and in today's Heart Declutter, we are going to be continuing on with my story of my autoimmune disorder. I know that talking about a thyroid probably isn't the most exciting thing that's going to be happening today, but seriously, stick around and you will learn something about your thyroid, especially if you have hyperthyroidism or Graves' disease. I think you're going to find this video super helpful. If you missed the first video, go ahead and click the link that appears on the screen right now to go watch that video first, or grab it down in the description box. So today I want to talk a little bit about what the function of the thyroid gland actually is. So we're going to go back to anatomy and physiology class for just a little bit, and I am a terrible artist, and so I found these pictures online, and I'm going to explain a little bit about what the thyroid gland actually does. Let's first talk a little bit about the location of the thyroid. It is located right below the Adam's apple or the windpipe, which is right here. It has two lobes, and people often say it kind of looks like a butterfly, which you could see that shape right there. The lobes surround the trachea, and then it weighs usually between 20 to 60 grams, and it's about 2 inches long. So it's a pretty tiny little thing, but it can wreak some serious havoc on your body if it is not working properly. So its job is to create a thyroid hormone, and those hormones are going to be what help regulate our metabolism, our growth, and our development. So let's get a little more acquainted with our hypothalamus. So the hypothalamus is located at the base of the brain, and it's responsible for the activity of the pituitary, which is its little friend right down here. So let's just give that a little bit of color. There's our little hypothalamus. Now it basically helps make sure that the body stays in a stable condition, or homeostasis as it's often referred to, and it releases TRH, and that is the short form for thyrotropin releasing hormone. It is going to release our TRH. Once the thyroid releases TRH, that is going to stimulate the release of thyroid stimulating hormone from the pituitary gland. So they work hand in hand. So we get a little bit of that. The pituitary gland is also located in the brain. It's kind of known as the master gland of the body. It's about the size of a pea, and it just sits right inside there. And its job is going to be to produce a variety of hormones. Now these hormones travel throughout the entire body, and they stimulate other glands like the thyroid gland. So in essence, the pituitary gland is regulating how much hormone the thyroid actually produces. So it does this by releasing the TSH, as we stated, and then the TSH is going to stimulate the thyroid gland to start producing its set of hormones. So the thyroid gland has receptors for the TSH. So let's draw in a couple of little receptors here. Let's just say those are our little receptors. Again, I'm not artistic. I don't have a clue what receptors actually look like. But in my mind, this is how they look. So that TSH that's produced is then going to go ahead, pop down here, and bind with those receptors. And now is where thyroglobulin comes into play. Thyroglobulin is an inactive hormone that is produced by the thyroid gland. So let's just write that in here. And let's fancy up our thyroid gland a little because, you know, it is the star of the show. So let's just outline this a little bit. So thyroglobulin needs to take in and absorb iodine, which is found in our food, in order to produce thyroxine. And thyroxine is the hormone of the thyroid. Let's draw in a little iodine here. So iodine is found largely in our food, and it's incredibly important for the thyroid hormone production. So if you don't have enough iodine in your body is actually unable to make thyroglobulin. So what happens is the thyroid is looking for iodine to absorb. So it's going to go searching all over the place for this little iodine here. And if it does not find iodine, it keeps getting, the whole thyroid keeps getting bigger and bigger and bigger in search of iodine. And that is what actually can cause people to develop goiters. So basically it's a swelling of the thyroid gland in search of iodine. But for our sake, we're going to say we get plenty of iodine. So the thyroglobulin is going to find its iodine. It's going to absorb it. It is going to split, and your end result is going to be T3 and T4, which are actually known as thyroxine. Now T4 is mainly inactive, and it's basically converted into T3. It is our active thyroid hormone. So I feel like it deserves a little color. Oh, what's wrong with that guy? So we'll give T3 a little color. Let's give T4 a little color too. So the thyroid gland is going to circulate T3 and T4 into the bloodstream. So as these guys circulate in the bloodstream, they have several jobs. Okay, so I was running off the page there a little bit, so I just whited that out and we're just going to come down here and do it this way. Like I said, clearly I am not very artistic or good with measurements. So anyway, as I was saying, these hormones control the rate at which cells and organs are going to turn nutrients into energy, so they're going to help with energy. They also help control our oxygen consumption. So we know that the red blood cells are what get oxygen into our bodies. So they are necessary for oxygen as well. It helps with clear thinking. And they also are going to help regulate our blood pressure and our heart rate. When we talk about metabolism and body function, we think of all of these things right here. So essentially these hormones are helping our bodies with homeostasis. And homeostasis is basically just referring to our body being in a stable place. So as these hormones are circulating in our bloodstream, they actually give feedback back to the pituitary gland. So we're just going to draw this little arrow up here, and they are still communicating with the pituitary gland. The pituitary gland is able to sense if more thyroxine is needed by the body. And if it does, it actually is going to go ahead and release more TSH, which then starts the entire process all over again. If there is plenty of these hormones within your bloodstream, it will not be releasing as much TSH. And this entire process is actually called the negative feedback loop. This is ideally how our bodies should work, but sometimes things get a little jumbled up, and this isn't exactly what happens. So how does having Graves' disease change this whole process that we just talked about? Well, Graves' disease is an autoimmune disorder that results in the overproduction of thyroid hormones, also known as hyperthyroidism. My body is essentially attacking itself or working against itself. So this whole negative feedback loop system is not functioning properly. There are several reasons why these dysfunctions can happen. They can be genetic, they can be environmental factors, they can be stress. It sounds like the jury is still out a little bit on this. No one seems to be 100% sure why exactly the dysfunction happens. My body was producing way too much T3 and T4. When I started getting my blood testing done, my T3 and T4 levels were extremely high, but my TSH levels, way up here, were actually incredibly, incredibly low. So there are different interventions that doctors use. I was put on methimazole. It's a medication that tries to stop the thyroid from producing all of these extra hormones right here. Now, this is why treatment can get really involved and complicated because there are multiple structures that are involved. It's not just the thyroid gland. Also the pituitary gland, the hypothalamus, are environmental factors that we talked about that could be causing it. When your body doesn't function at its optimal physiology, there are going to be some obvious signs and symptoms like the ones I talked about in my previous video.
Irritability and agitation. Can't spell and talk at the same time, it's very challenging. Oh my goodness. Okay, agitation.
I had increased blood pressure and heart rate, which I remember very distinctly. Very high resting heart rate. I believe at one point my resting heart rate was 200 beats per minute. Probably the average person's resting heart rate for someone that is healthy should be probably around 60 beats per minute, and mine was 200. So yeah, I felt like I was constantly running a marathon. And then you can also get the eyes bulging. So the eyes start to bulge because pressure is building up behind the eyes. You also are going to have increase in body temperature. You also lose weight. And that makes sense because your heart is beating so fast and it's beating like that all the time that it's like your body is in a constant state of very high excitement and high energy. So decrease in weight. And just kind of an overall restlessness. And I would say that's probably even more than being irritable. I was very restless. When I was first experiencing all of these symptoms right here, I had my TSH levels checked and they were very low, which is very indicative of a thyroid dysfunction, and in my case specifically, Graves' disease and hyperthyroidism. The job of the thyroid hormones right here, that clear thinking, the regulating that heart rate and blood pressure and getting that oxygen to where it's supposed to go, these are now very dysfunctional. I was experiencing all of these things and it was time for a bit of an intervention, and that's coming up in my next video.